So, yeah, this is what we're doing today. I just said, sorry, I haven't cut and paste and popped it on Daymap. I will. But yes, people are then saying, oh, we don't look at Daymap. Anyway, okay. So I'd like to think that you have done this already from the work before, but it's a good recap to revisit or for the first time, look at it for some of you. This is the exact same question that we had in your new book. It could be that they've got the exact same questions underneath. I don't know. They seem to hide this question a little bit. They pop it in some of the reviews. But anyway, what I would like you to get out of this is knowing our position vectors. So, and writing vectors nicely. So get the scene. We've got 2 points. We've got A and B. We've got the point P is somewhere in the middle of A and B. In the ratio, it's 2:5. So you can put the 2 here, you've got the 5. So how many parts altogether? 7. So do you agree? What we want to do is we want to get the vector OP. And that is making you remember that if I have a point, I'm going to use a different point altogether. Let's say the point C, and that is, let's say, I don't know, 4, 7. The position vector, and we'll talk about this in our investigation. So OC, origin, O is 0, 0. So OC, great show, would be 4 take 0, which is 4, 7 take 0, which is 7. That allows us to find various bits and pieces, but it also means that if I want the point like we've got here, if I can find OP, and I end up getting that the vector OP is, I don't know, 10, 12, therefore that allows me to say that the point is then 10, 12. Does that make sense? So that's where we're going with this stuff. All right. So hopefully you get the gist over here. Oops. That what we've got A, we've got B, P is in the middle, so we want to find OP, so that's going to be OA plus AP. Agreed? OA, we will know it'll just be minus 3, 2, but what is AP? It's going to be a fraction of the vector AB. Right, and it's 2/7 because that's 2 parts, the whole thing is 7 parts, so 2/7 of AB. Correct? You whack it in, we solve it, we'll get the point. Pretty simple. But if you hadn't practiced, if you hadn't revised it, if that lobbed in a test question, which if you look back at previous tests, it's likely to, you're going to be a little bit lost. Okay? So let us practice. Shall we do one together? Don't necessarily have to go to scale with this, but I'm going to try somewhat, not to scale, but roughly. So we've got 3 minus 1, and then B is minus 3 and up 4. So we know we're heading, I'll pop that there, minus 3, 4. It's always good just to have a little bit of an idea of where things are. Correct? All right, and Q is somewhere there. It divides AB in the ratio 1:3. So we can probably put it roughly here. Okay, so we've got Q, and we've got 1:3. 1 part to 3 parts. All good? Now, I know that the origin is going to be somewhere wherever. I just stick it anywhere. I don't really mind. Okay, so what we're wanting is we want OQ. Agreed? I think there's 2 ways that we can get OQ. Who can tell me one way of getting OQ? So like the example, if we go with, so it has to be the same bit, so OA and then AQ. Do we agree? So we can have OQ equals OA plus AQ. Who could give me another way to get OQ? Sage? Yep, to B. So that would be OB plus BQ. Would it matter if I had said QA plus AO? So I've got nodding of the head. Why would it matter? What would the vector QA plus AO give me? It would give me QO, which is not what I want. It would be the minus reverse of that. So your direction is really important when you do this. Agreed? All right, so away we go, and we can do this pretty quickly now. So OA, we know that that just turns into the position vector 3 minus 1. We've got AQ is what fraction? So A to Q is what fraction of A to B? 1/4, okay, because you've got one part here, 3 parts, so 4 parts altogether. So it's going to be 1/4, thanks mate, of AB. And so now we're reminding yourselves, how do we find a vector between 2 points? If I want AB, it's B minus A. So minus 3, take 3 is minus 6, 4, take 1 is 5. It seems really simple, but I tell you what, even when I'm doing some of these questions, there's negatives all over the shop, there's which one take which. I don't know why, but lately I've been switching my X's and my Y's. Don't ask me why. Don't do it, concentrate. Okay, so that means my OQ will be 3 minus 6 times 1/4 and minus 1 plus 5 times, 1/4, which we can find out. Okay, therefore Q is the point 3/2, 1/4. Would it mean that you would lose a mark if you didn't write it like this? Yes, because you need to know the difference between a vector and a point, a coordinate, and that's how we write them differently. Back in my day, I think I told you at the start of this unit, we used to represent vectors like that. And so it was really, you had to be really good with your penmanship. If you were messy, and I was like, oh, is it a square bracket, is it a round bracket? We used to go hard. So give you a nudge on this one, which I think is quite nice. But again, this is an example of you have the skills to do this already. It's just a different type of question. So if you are thinking, oh my God, this is so obvious, maybe I'm wrong. No. What do you think we would do? Oh, so this was, because it's from the old thing, these are vectors, okay? So this is the same as if we had R 1 minus 1 plus S 2, 5. Like I've spent most of my maths life writing vectors in the square brackets and trying to convert over. But anyway, so what could we do? Probably looks easier, I think, when it's like that, but who knows? Maybe it's not. Pardon? Yes, does algebra to solve? What do you mean? So what's one thing that you could write down, or two things? Maybe two equations. Thinking hats on, come on. Don't go to sleep. Come on. This is, again, I'm not really overly concerned about the final answer here. It's about what do we do when we are faced with something a little bit different. And we go, okay, what are some of the skills that we could do? And you're looking at me going, I don't know what to do. What's something that you could do possibly with the left-hand side? Is there anything you could do? Ella has just said, add them. I think that's a great thing to do. So r times 1 would be r and minus r, right? Plus 2s and 5s. So what would the left-hand side end up being? R plus 2s and, thank you, Tom, yep, minus r plus 5s. Right, equals, oops, minus 8 minus 27. Now, is there anything that you could do? What would we divide? And remember, with vectors, we don't like to divide anything. So, no. Anything? What do you mean? Right side onto the left side. But, okay, another little clue. Is this possible? Is that possible? No. Because the vectors, they can't, if I had 3, 4 equals xy, what must x be?
3.
What must y be?
4.
Please apply. I'll underline again. Hello. Say that again, please. 2 separate equations. So what's my first equation? R plus 2s is equal to negative 8. Love it. And minus r plus 5s equals minus 27. Now you could go running to your graphics calculator because these are 2 simultaneous equations, right? But hopefully you go, please, it would take me longer to type this in than to actually solve. Because what do we notice about r and minus r? They cancel each other out. So if I add these equations together, r plus minus r, no r. 2s plus 5s is 7s. What's minus 8 plus minus 27? Oh my goodness, it's minus 35. Therefore, s is? Thank you. That's great. How does that help me find r? Right, sub it back in. Excellent. So r plus 2 times minus 5 is minus 10 equals minus 8. So therefore r must be 2. Yo. So Matt is saying, we'll say that again. I just removed the brackets and put in an extra equals. Now, again, I only wrote this line down because this is the first time you've looked at a question like this. And so it's going around with, don't just do nothing or just stare at it. Put pen to paper. Right? I asked you, what's something that you could do? Just do something. So someone came up, Ella, I think it was you, simplify the left-hand side. We did it. As soon as we did that, then the next bit connects. So use that for all your maths, not just in spec, methods as well. Always do something and go forth. And yeah, to be honest, would I actually write this line in? No, I'd probably go straight to this from the equations that I was given. So r plus 2s has to equal minus 8 and minus r plus 5s has to equal minus 27. I'd go straight to. Yeah? But this sums up what we're doing at the moment. Not too bad, but how does one start? And my job is to try and give you some unfamiliar questions in your test. Not all of them, just 1 or 2. The way that you can counteract my efforts is to do as many questions as you possibly can. Good luck. Now, we've got 20 minutes remaining. So far this lesson, you've been reminded about simultaneous equations. We've been reminded about position vectors and adding vectors, whatever. We've got ratio that we've covered, so a lot of little different things. I just had my hand over the mic, sorry about that. All right, now we go on to something a little bit different. So let's have a look at this. Find the coordinates of point B, which is 4 units from another point, and in the direction of 2, 1. And we want to find point B. So once again, we are using our position vectors, right? So we've got O to A. We're travelling 4 units along in this direction. So if I can find the vector OB, that means I could then state what point B is. Agreed? So let's go back. How do I find a vector that's a certain number of units in the same direction as another one? Try not to look at the answers. What do? Pardon? Times what by 4? Think of the strong sun. Unit vector, UV, the rays. Right, so we want to find the unit vector of this one because that's going to be heading off in 1 unit in the same direction. And if we want to go in that direction by 4 units, then we just times it by 4. Add those vectors together. That will actually give me OB, and then I can find B. Make sense? So let's put this into practice. They've got that example there for you. I think that was a question they got you to do in the new book. I'm not quite sure, but anyway. All right, so find the coordinates of B, which is 3 units from the point A and in the direction 1, 1. So once again, we're going to pop there. I'm feeling green. We've got A. We're heading off in the direction of 1, 1. So heading off in that direction towards the point B. And we're going to find, right, so O, A. Oh, boy, oh. One of those mornings. So OB, O to B, will equal OA. Yes? Plus, now how far are we going? 3 units. So I don't know how you write this, but I'm going to go 3 times the unit vector of 1, 1. Just so I know what's going on. Does that make sense? Okay, so away we go. We know that OA is 4, 2. That's pretty straightforward. Now we're going to say 3 times the unit vector of 1, 1. How do we find a unit vector? See, good revision. Quick, unit vector. We have to first find its, rhymes with tenth.
Length.
Thank you. We have to find its length. What is the length of the vector 1, 1? Root 2. So we're going to times through by 1 over its length. Happy days? Okay, so if you really want to, you can write it all nicely if you so desire. I can't be stuffed. So I'm going to say this will be 4 plus 3 root 2 and 2 plus 3 root 2. Okay, obviously if that was a 4, I would say 3 root 2 times 4. Got it? Hit my calculator up. So therefore the point B would be 4 plus 3 root 2, comma 2 plus 3 root 2. And as I said, I would probably hit my calculator now to write it as, I don't know, to 2 decimal places. Yeah. So this one, what's the whole point? What do you think they're trying to remind you of in this one? I and J. So you go, please, I know this. This is 1 minus 1. So it's going across and down. So we've got, here's A. We're heading off in this direction 2 units, but in the direction of 1 minus 1. This is meant to be B. Okay, so once again, OB will be OA plus 2 lots of the unit vector 1 minus 1. Okay, So we're not messing around here. Let's do this swiftly. They shouldn't take all day. All right, it's 2 times, now once again, 1 squared plus minus 1 squared, root 2, 1 minus 1. So we get our vector 3, 2 on root 2 times 1, so 3 plus 2 on root 2. Your calculator won't like that, and we shouldn't like that, having a square root, a surd at the bottom. You could times by root 2, top and the bottom. You could just put it into your graphics and it will do it for you. And then the bottom one will be minus 4 take 2 on root 2. Okay? Therefore, state your point B. Use your graphics calculator to give it in an exact form, but then also in 2 decimal. Okay? All right, so please finish those. Take the time to summarize, make your notes. You should already you shouldn't have to go, oh my God, here's my help sheet right before the test. You should be getting in action. Review set 3A. Start progressing. Okay? As I said, we've just got vector geometry to do, but might save that just for a little bit later. We're going to stick with the numerical stuff for now. Yes, hands up. No, stretching. All right, good luck. Love you, love you, star. Yep.